This is the first day presentation of section 11.2, areas of circles and sectors. Let's take a look at a problem here. So Steve, Ashley, and Owen are each trying to build the tallest snowman. So right now you got to think in the background, you know, that song from Frozen where you want to make a snowman, right? So this is setting the mood. Each child has the same amount of snow and wants to make the tallest snowman. And Steve says, geez, you know, if I make fewer spheres, that'll be the tallest snowman, so I'll just stack two on top of each other. And Ashley says, no, I think that we should do more and make them smaller, so I'll stack 10 of them of equal radii. And then Owen says, okay, you guys are just crazy, right? It doesn't matter. I can just make as many as I want, and all of our snowmen are going to be exactly the same height. So I'm just curious, which one do you think is correct? Do you think Steve is right, or Ashley is right, or Owen is right? I suppose I could give you the answer, but maybe I'll wait until tomorrow to give you the answer to this. So think about it, and I guess I'll revisit this problem tomorrow briefly. So we're going to talk about calculating the area of a circle and the area of a sector. So a sector is just part of a circle. So sectors can be major or they can be minor. So a sector is considered major if the arc that contains it is greater than 180 degrees. If it's less than 180 degrees, then the sector is considered minor. For the most part in this section, we'll probably be dealing with minor sectors, but once in a while that major sector could come into play. And don't just always assume it's a minor sector. So this is my favorite sector of all time, and I don't know if you've got a favorite sector or not. Of course you do. I mean, of course you have to have a favorite sector. But this is my favorite sector here. This is Pac-Man. And is this a major sector or a minor sector? Well, if I take a look at this, it's really pretty much almost all the entire circle. So in this case, this is a major sector. So my favorite sector is a major sector. So the formula for finding the area of a circle is pi r squared. To be honest with you, I'm expecting you to already know this. So circumference is a different formula than area. Area is pi r squared, right? And circumference is pi times the diameter of a circle, but area of a circle is pi r squared. So let's take a look at an example. So if a circle has a radius of 3 inches, what's its exact area? The key word here is the exact, okay? Which means then you're not going to be taking 3.14 times your number. You're going to leave it in terms of pi. So the radius is 3, so I square that number to get 9, and the area of this circle is 9 pi inches squared. Let's take a look at a new type of example. So if the area of a circle is 16 pi meters, what's the diameter? So this one's a little tricky. I actually thought I might trick you up on this, but we basically just fill in the formula. I'm going to go 16 pi equals pi r squared. And then once I've got that set up, I can divide both sides by pi to get the pi's to go out of the way. And we'll be left with 16 equals r squared. But in order to figure out the radius, I need to take the square root. So the square root of that 16 becomes 4 meters. And a lot of times students will make that answer and just go with it and say 4 meters and I'm done. But that's just the radius. So in order to get the diameter, you need to multiply that number by 2. So the diameter is 8 meters. So last section you looked at arc length. Arc length was just fraction of circle times circumference. Today we're going to be doing area of a sector. Area of a sector is just fraction of circle times area of circle. So again, this formula looks really daunting, but it's really not that big of a deal. You just take the fraction of the circle that the sector is, multiply it times the area of the circle, and you've got the area of the sector. So let's take a look at it. I want to find the exact area of sector ACB. So sector ACB is this red sector in here, okay? So first thing I want to do is find the area of the circle. The radius is 8, so 8 squared is 64. So the area of the circle is 64 pi centimeters squared. Then I want to figure out how much of this circle is this sector. So I'm going to take 60 over 360. So this is my central angle of 60 degrees, which is going to be 60 over 360. That becomes 1/6. Okay. So 60 over 360 is 1/6, and then I just take 1/6 times 64 pi centimeters squared. And that's not going to make a nice, beautiful, wonderful number. It's going to be kind of a funky number. In this case, it's going to be 64 over 6, which is going to reduce to 32 over 3 pi centimeters squared. So if you want to make this a mixed number and go like 10 and 2/3 pi centimeters squared, that's absolutely fine. All right, so I want to find the area of these sectors here. So first thing I need to do is find the area of the circle. The radius is 14, so that's going to be 14 squared times pi, and that is 196 pi. So this area of the entire circle is 196 pi feet squared. And then we got to figure out areas of sectors. So we'll start with the yellow sector. That's 120 degrees. That's a third of the circle. So I'll take a third of the circle times 96 pi, and I'll get 65 and a third pi feet squared. And then to do the green one, I could either take this number and subtract the 65 and a third to get the area of the yellow one, or I can just do 2/3 times the area of the circle. And I just did 2/3 times the area of the circle and got 130 and 2/3 pi feet squared. Or you could have just doubled this. Either one of those would have been a fine way to do this problem. All right, so here's the deal. If I ever give you a problem, or you're ever presented with a problem where you're given just the area of the sector, so notice this sector is green and the area is 40 meters squared. That's the area of this sector. And any type of problem, no matter what I'm asking you to do, you will always have to get the area of the circle every time, okay? No matter what I'm asking for. If I ask for the radius, I ask for the diameter, I ask for the area of the white sector, okay? Or I ask for the area of the entire circle. It doesn't matter. You have to get the area of the circle in order to figure out any other part of a problem that involves an area of a sector, okay? So this is really important. That's why I highlighted this, okay? If I give you the area of a sector, you always have to figure out the area of the circle, even if that's what I'm just asking for. I might just ask for the area of the circle. But I ask for anything else specific, then you still have to get the area of the circle. So let's take a look at an example here. So I want to find the area of the circle. So this is 40 meters squared, the area of this sector. So I'm going to just fill out my formula to figure out the area of the circle. So area of sector equals whatever the fraction is of the circle times area of circle. So the area of sector is 40. So 40 equals, in this case, 110 over 360 times area of a circle. And that's what we're going to be trying to get, is this part of the formula. So again, 40 equals fraction of circle times area of circle. So how do we figure out the area of the circle? Well, we've got this funky fraction here, which you could reduce to 11 over 36 or leave it at 110 over 360. But in order to isolate the area of the circle, which is pi r squared, I'm going to multiply by the reciprocal of 110 over 360. So both sides are going to get multiplied by 110 over 360, or in this case, I obviously simplified it first to make 11 over 36. I multiply by 36 over 11 on both sides. That cancels the fraction, leaves me with the area of the circle on one side, and the area of the circle in this case then is going to be 130.9 meters squared. And area of a circle is this. So in this case, you're getting basically isolated to two variables. You're isolating it to pi and to r squared, but this whole part is area of a circle. So what you're isolating in this type of problem is area of a circle. All right, same problem, but I want to get the white part. Okay, it's like, how do I figure out the white part? So same deal. It's the same exact problem as the previous one. So we got to figure out the area of a circle. So this is going to be 110 over 360 times pi r squared equals 40. I'm going to simplify it. I'm going to get the area of the circle at 130.9. And then if I want to figure out the white part, the easiest thing to do would just take the area of the circle, which in this case is 130.9 meters squared, and subtract the 40 that we know. So just subtract the area of the green sector. That leaves the white sector at 90.9 meters squared. All right, same problem, except I want to get the radius of the circle. So same deal. I've got to figure out the area of the circle, which we've already done. Okay, it's 110 over 360 times pi r squared equals 40. We get it all the way down to 130.9, and that gets us pi r squared. And then in order to figure out the radius, I'm going to divide both sides by pi. So both sides here are going to get divided by pi. And that's going to leave me with 41.7 equals r squared. And then I'm going to take the square root to figure out the radius. So the square root of square root of 41.7 is 6.5. So the radius of the circle is 6.5 meters. All right, so let's try a completely different problem now. So you've seen basically the same problem done a bunch of different ways, but let's take a look at this one. So it's a new problem. I know that the area of the sector is 35 meters squared. The sector is 40 degrees. So I'm going to go 40 over 360, which reduces to 1 over 9, times area of circle equals 35. And then I'm going to, I think it's easy to reduce this to 1/9 first. If I reduce this to 1/9, then in order to isolate pi r squared, I multiply both sides by 9. So 35 times 9 is going to be 315. So I'm left with 315 equals pi r squared. Divide by pi, that isolates r squared. And then I need to take the square root of that number. So I get 100.3 for r squared. And then I take the square root to get a radius of 10 meters. All right. So I think we're pretty close to the end here. So it's like find the approximate shaded area. So you want to find the shaded area here. And students will be like, oh my gosh, that's so hard. But it's not. It's like super easy. If you look here, there's a square. And also inside of this figure is a circle. So if I take the area of the entire square here and I subtract the area of the circle, that's going to leave me the area of the shaded parts. This is not that terrible. So I find the area of the square. So square is side times side, so 18 times 18 is 324 inches squared. Then I got to find the area of the circle. So that's pi r squared. So what's the radius of this circle? Well, if this is 18 all the way across, the radius is 9. And then 9 squared is 81. So the area of the circle is 81 pi. And then all I have to do is just subtract these two numbers. Take 324 minus 254.5, and I get 69.5 inches squared is the area of the shaded part here. All right. So this concludes the first day presentation of 11.2. On Tuesday, I want you to do just problems 2 through 9. Don't send it to me. Hold on to them. And then on Wednesday, I want you to do problems 11 through 17. And then on Wednesday, I want you to send the entire 722 to 723 assignment, 2 through 9 and 11 through 17. And I hope you found this presentation helpful.